So, moving on to the third part of this lecture series, we're going to take a closer look at how we can explain success or failure in these risky enterprises and organizations. So, what are the types of features and conditions that might contribute to relative success or failure? But the first thing we need to think about are that there are two basic perspectives on how we actually can regulate risk. So one might be a more compliance-oriented perspective, where the goal is, in essence, to avoid the bad outcome. It's going to be very forward-looking and preventative. And the idea behind this is the basic way you can actually ensure this is you need to have early detection of deviance so that you can do something to prevent the negative outcome. With a deterrence-oriented response, in essence, there's an assumption that what you need to do is deter bad outcomes through costly sanctions and penalties. So instead of having a more sort of, there's a problem with, say, the set of conditions or the work processes that is causing failures, is instead that what you need to do is really punish people for making a failure. It tends to be very backward-looking and punitive. And if you can punish the deviations that lead to mistakes, the idea then here is that you can basically eliminate these mistakes. So these two approaches basically have very different ideas about how you actually contribute. What is it that's contributing to the error rate? So in some cases, a more compliance-oriented approach is going to think about system features of the enterprise and establishment that might, in essence, affect our ability to both detect error and respond to error. Environmental conditions could also be there in a more compliance-oriented approach. Could be an issue, but in some cases, these environmental conditions, we're going to assume that these are ones that are perhaps not able to be addressed through system features. But in some cases, you can actually address these environmental conditions through system features, in which case, again, you're taking a more compliance-oriented approach. The third possibility is that basically these are people problems. So these are the three potential explanations of what's contributing to the error rate, or your ability to detect and respond to error. And people problems are basically most associated with the punishment-oriented approach to deviance. And so one of the things that we're going to think about in this class is we're going to assume, in essence, that there might be some people problems, but that they're random or erratic enough, or that our system should be somewhat robust to potential problems with people, at least to the most part. And to the extent that we have any people problems, what we're going to want to try to do is put in features, etc., that say monitor people and can in some cases respond to it, whatever the issues are, or train them adequately so they don't make mistakes simply through lack of knowledge. So in essence, when we're thinking about these, thinking about both sort of a compliance-oriented approach or this more punishment-oriented, we're going to think more preventative or punishment-oriented. We're going to try to think about how we can incorporate features of both of them without sort of having to choose that it's just one or the other. One thing to keep in mind when we're thinking about detecting errors and then preventing them is that in some cases, a lot of the times, there are anomalies. A set of conditions is very likely to lead to an error that is not addressed. So in the case of planes, for example, if they get too close to each other, they might fly into each other, boom, or if a plane is coming into the ground too fast, it might crash. So this would be the types of conditions that might lead to an error. The error are the outcome conditions that constitutes failure. So an anomaly says it hasn't quite failed yet, but there's a problem, there's a warning that you might fail. And an error are the actual outcome conditions, for example, a crash or the loss of life, that actually constitute an actual failure with respect to the desired outcomes. So one of the interesting things that this sort of drawing this line between anomalies and errors gives us is that in some cases where you have a good knowledge of the types of conditions that can lead to total failure, you can actually identify these lower level errors that are far short of complete failure. So whether or not planes get close to each other, or whether or not in the case of our landings on the aircraft carrier, if two planes bump even just for a little bit, or one plane overshoots and goes up in the sky a little bit, those are anomalies, but that doesn't necessarily entail a crash. But nonetheless, we can call them in essence, errors, but they really are anomalies. They are things that stop, a set of conditions that stop just short, but they are likely to lead to error if they get repeated. So in essence, then, with an ICS, you might think of property damage and lives lost as the error, but anytime you get something like an unexpected explosion or a surprise, maybe the fire isn't going out quite right, maybe you run into, say, an unusual building construction or location of chemicals, etc. These are anomalies that are basically conditions that require an alert back and a potential change. So in terms of assessing conditions, when you assess these anomalies, like fire not going out, as we go back to the wildfire, the Man Gulch disaster, right? They got there and all of a sudden the fire wasn't going quite right, or the wind picked up. And so these were all anomalies, changes of conditions that they thought could lead to possible errors, i.e. lives being lost or more property being damaged. With the naval air, again, you get basically planes damaged or lives lost. So planes crunching, which is whenever they just touch. Actually, intrusion into these foul lines, again, that's or missing the wires. These are the two I just spoke about. Changes in wind direction. These are exogenous effects that nonetheless can lead to increases in errors, and also deck accidents. So even when it's not involving planes, but when two people trip, or in other words, in any way, sort of do things that might lead to potential errors, especially in high tempo conditions, are all considered anomalies that need to be tracked and responded to, and are defined as such within the system.